This is my submission for chapter 26 exam. The first question states, you have three resistors. R1 is equal to 1 ohm. R2 is equal to 2 ohm. And R3 is equal to 4 ohms. Find the equivalent resistance for the combination shown in figure 1. So in order to get this, we're going to use the formula R equivalent for the equivalent resistance. So equivalent resistance is equal to R1, R2 plus R3. And then we just plug our values in. This would be 1 plus 2 plus 4. And then this is equal to 4, 5, 6, 7. 7 ohms. And this would be the answer for part A. Part B is asking to find the equivalent resistance for the combination shown in figure 2. So for this, we're going to use this formula. 1 divided by the equivalent resistance is equal to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. And then here we just continue plugging our values in. R1 is 1 plus R2 is 2 plus R3 is 4. And then when we solve this, basically I'm just gonna put it in calculator really quick. So this is 1, so it would be 1 over 2 plus 1 over 4 equals no, I'm just gonna do the math. So here 2 plus 1 divided by 2, this is equal to 3 divided by 2 plus 1 over 4. 2. This is equal to 6 over 4 plus 1 over 4. And this is equal to 7 over 4. 7 over 4. But this, we have to take out the inverse in order to find the equivalent resistance. So when we take out the inverse, we get REQ is equal to 4 over 7. Basically, we just flip this around. Ohms. And then this is equal to 0.571 ohms. And this is our answer for part B. For part C, we're asked to find the equivalent resistance for the combination shown in figure 3. So here, we're going to use the formula R equivalent is equal to R2 times R3 divided by R2 plus R3. This is equal to 2 plus 4 divided by, 2 times 4. And divided by 2 plus 4. This is equal to 8 over 6. And, I forgot a part of this formula. This is R1 plus. So our R1 is 1 here. So it would be 1 plus 8 over 6. So here 6, 8 plus 6 over 6. And then this is equal to 14 over 6. Yes. You divide this in half. Well, this would be 7 and this would be 3. And then this is equal to 7 over 3. And when we plug this into our calculator, we get 2.33 continuing. Can't remember the exact name for that, but basically it just continues 2.33333. And that is our answer for part C. For part D, we are asked to find the equivalent resistance for the combination shown in figure 4. So for that, what we're going to do is basically use the following formulas. So from this, I guess what we're going to use is R prime. So let's just get started. So REQ is equal to R prime plus R1 divided by R prime times R, well, I got this backwards. R prime times R1 divided by R prime plus R1. And then this is equal to 6 plus, let's see, 6, because this is 1. And then 7. This is equal to 6 over 7 ohms. And then this is equal to 6 divided by 7. 0.86 ohms. And that would be our answer for part D. For part E, we are asked, you have 3 resistors. R1 is equal to 6 ohms. R1 is equal to 6 ohms. R2 is equal to 8 ohms. R3 is equal to 10 ohms. And then we're given, well, I'm just going to continue the question. Connected as shown on figure 4. The terminals of a battery with M24V, this is the M, and negligible internal resistance are connected to points A and B. Find the current through the battery. So for this, we are going to use same formulas that we used previously. This would be 1 divided by the equivalent resistance. So here it would be 1 over, well, actually, before we get here, we need to get like the total equivalent resistance. So this would be equal to R23, like the equivalent resistance of 2 and 3. So R2 plus R3. And then here, this would be equal to 8 plus 10. And this is equal to 18 ohms. So this is what we're going to use in this formula right here. So 1 over 18 for the total equivalent resistance divided by 1 over 6, or R1. And then this is equal to 4 over 18. And then since we need to inverse this, this will be equal to REQ is equal to 18 over 4. And then this is equal to 4.5 ohms. So after this, we're gonna use the following formula of I is equal to V divided by R. So here we're just gonna plug our values in. We're given our M, which is 24, and we have our resistance, which is 4.5. And when we plug this into a calculator, we get 5.33 continuous A. Because this is an electrical current, we need to use the proper units. So that's the answer for part E. For part F, we're gonna continue using the same formula. We're asked to find the current through R1. So this is gonna be the current of R1 is equal to V divided by R1. So this is equal to 24, or M that we're given, divided by 6, and then this is equal to 4A. So that is our answer for part F. For part G, we're asked to find the current through R2. So this would be equal to I is equal to, here we just need to subtract the two currents that we have in order to find the one for R2. So this would be 5.33 minus 4, and then this is equal to 1.33a, and that is our answer for part G. For part H, we're asked to find the current through R3. So in order to do this, well, actually, since the current is flowing, yeah, I remember this one. I was trying to figure out why it's the same, but this is the same current as basically what we just found for R2. And why is this? This is because the current is flowing through the 18 ohms resistor, and this is like a series combination of R2 and R3. So the currents across both R2 and R3 would be equal. So the current for R3 would also be 1.33. So that is the answer for part H. For part I, we are asked, you have 3 resistors. R1 is equal to 7 ohms. R2 is equal to 8 ohms. And R3 is equal to 9 ohms. Connected as shown on figure 2. The terminals of a battery with EMF, we're given our EMF, of 12V, and negligible internal resistance are connected to points A and B. Find the power output of the battery. So we're asked to find the power. In this case, we're going to just continue using the same formula. Well, we need to find the equivalent resistance first. So this is equal to 1 over 7. We're going to use that one, plus 1 over 8 plus 1 over 9. And then this, I put it in the calculator, and this is equal to 191 divided by 504. We're not going to round just yet. We'll get to that later on just because it'll be easier instead of dealing with decimals already. So, again, we're going to use the formula for current. This is equal to I is equal to V divided by our resistance. And then this is equivalent to P is equal to V times I. And then this is equal to V squared over R. So basically from this formula, we get to this formula in order to find our P, because we have these values. So I'm just going to come over here. This is equal to P1. Well, actually, no, we're not there yet. Let's just use P for now. Is equal to 12 squared, because it's our V squared or M squared, divided by 504, because we're gonna use this that we just found in order to get this solution basically. And then this would be equal to 191. And when we plug this into a calculator, we get 54.57 of work. So that would be basically the power output of the, well, not work, watts. That would be the power output of the battery. 54.57 or 54.6. So that is our answer to that question. So this is where the P1 comes from, because on part J, they asked us to find the power output to R1. So here we are going to use our P1 is equal to V squared divided by our resistance. Once again, we know that our EMF is 12 divided by R. And we use our, we're going to use, let's see, 7. We were given a 7. And then this is equal to 20.57. So that is our answer for part J. For part K, we are asked to find the power input the power input for R2. So same deal, V squared over R, 12 squared divided by the resistance that we were given. This is 8. And then this would be equal to 18. That is our answer for part K. And then for part L, we are asked for the power input to R3. Same deal. P3 is equal to V squared divided by R. This is equal to 12 squared divided by a resistance given earlier on of 9. So this is equal to 9. And then this all equals 16. So that is our answer for part L. Now, we are asked in part M. You have 3 resistors. R1 is equal to 5 ohms. R2 is equal to 6 ohms. And R3 is equal to 7 ohms. Connected as shown on figure 3, the terminals of a battery with M of 9V and negligible internal resistance are connected to points A and B. Find the power output of the battery. So in order to find the power output, we're going to do the same deal that we did for the previous problem. We are going to, let's see. What can we do over here? R23 is equal to, we're going to use 2 and 3, of course, because R23. So this is 6 times 7 divided by 6 plus 7. This is equal to 42 divided by 13. So our equivalent resistance is equal to R1 plus R23. And then this would be equal to 5 plus 42 divided by 13. And this is equal to 8.23. So then we're going to use the formula for our current. This is equal to I is equal to V divided by our equivalent resistance. So V, we're given, our 9 amps, divided by 8.23. This is equal to 1.09 A. Okay. So, let's see. We are going to, actually, now, okay. So, now that we have our current, we're going to use the formula P is equal to VI. And then, VI, this is equal to V that we're given times our I that we just found, 1.9, and this is equal to 9.81. So that is our power output for the battery. Okay, so part N. We are asked to find the power input to R1, but in order to find the power input for R1, we need to find the current for R2. So this is equal to I times R3 divided by R2 plus R3. This is equal to 1.09 times 7 divided by 6 plus 7. And then all of this is equal to 0.59 A. Okay. So that is for R2. And then we need to find our current for R3. Okay, so this would be equal to I, of course, times, here we're going to use R2 divided by R2 plus R3. This is 1.09 times R2 is 6 divided by 6 plus 7. And then this is equal to 0.50 A. Okay, now that we have those values, we can go ahead and find our part N, finally. So P is equal to R1 is equal to I R1 squared times R1. So this is a formula that we're going to use basically to find everything, current times resistance for each one. So this would be equal to 109, our current that we know, squared, times 5 that we know from our problem. And this is equal to 5.9. So that is our answer for part N. For part O, we're asked to find the power input for R2. This is equal to PR2 is equal to I R2 squared times R2. This is equal to 1.09 squared times, well, actually, no. See, this is where we have to go back because it's not the same. We found different currents for each one, so we're going to use the respective current for each. So for 2, our current was 0.59. And this is going to be multiplied by our given resistance. And then this is equal to 2.09. So that is our answer for part O. And then for part P, same deal. P R3 is equal to I R3 squared times R3. This is the 0.50 that we found squared times our given resistance, which is 7. And then this is equal to 1.75. And that is our answer for part P. So this would be my submission for exam chapter 26. Thank you.